Hi, we are Rodrigo Covarrubias, Alberto Toledano, and Luis Carlos Caraves. We are group number 2, given by Marilu Paredes, and we are going to solve the problem number 3 that says that a snowball melts, that its surface area decreases at a rate of 0.1 inches squared over minute. So we have to calculate the rate of change of the volume when the radius is 12 inches.
The data that the problem gives us is the decreases rate of the area, that is 0.1 inches squared over minutes, and the radius is equal to 12 inches.
Well, now the formulas we need to use for solve the problem is by the problem asks us for calculate the rate of change of the volume, and this is a formula of the volume of a sphere. That a snowball is like a sphere, and it's 4/3 times pi times radius cubic. But
we need to derive the formula of the volume, that is this one. So when we derive, we multiply this number, the one that is in the radius, times 4/3, so it's 3 times 4/3. So the 3 goes off with this 3, so we only have 4 pi radius squared because we subtract 1 from the 3, so it's radius squared. So we have already our derivative formula from the volume, but we know in this formula that we need to have this part also. So we go to the formula of the area, that is 4 pi radius squared. So when we have this formula, we need to derive also. So we derive the formula, and it is 2 times 4, that is 8, radius pi times radius dr over dt. So in this part we already know that we have the dA over dt and the radius. So the only thing that we need to do is the dr over dt, and to get that we need to clear all the equation except the dr dt to leave it alone. So when we leave it alone, we got this because all this part is multiplying the dr over dt, so we pass it dividing, and when we pass it dividing, the only thing that we have to do is put the values of each thing. So dA over dt is 0.1 inches squared over minute, and 8 pi times pi times radius, that is 12 inches, that is in here, and the only thing that we have to do is to resolve this equation, and this is the dr over dt.
now, well, that we already have the missing value, we only have to substitute each value of the derivative of the volume. So it's 4 times pi times 12, the radius square, times the dr over dt, and we have the rate of change of the volume of the snowball.
In conclusion, according to the answer, we know that the snowball is melting at 0.5998 inches cubic over minute every minute. Thank you. We solved the problem number 3. Thank you.